ओके, गुड मॉर्निंग एवरीबॉडी। सो मैट्रिसेस में हम लोग काफ़ी फाइनल स्टेज में पहुंच गए थे एंड वी वर डूइंग प्रॉब्लम्स रिलेटेड टू सिमिलरिटी ट्रांसफॉर्मेशन एंड फंक्शनल मैट्रिसेस। ओके, सो लास्ट वाली प्रॉब्लम आप लोगों ने बाद में ट्राई किया था? हैव यू ट्राइड दैट?
Yes, sir.
सो आई विल जस्ट write again what we were discussing in last class. So I took a matrix A, and please remember this is a previous year question, so you should do it properly just to understand complete thing. This will give you a complete picture. 0 A and 0 A 0 and 3 cross 3 matrix. Okay, so can you see that this matrix is a symmetric matrix? Can you see that? If you take the transpose, what you will get? The same matrix? Yes? A00 and then 0 and 0A0. So that means eigenvalues क्या होंगी?
Real.
Real, and that you will see that it is minus A and A. Correct? And also you have degenerate eigenvalues. And further, the eigenvectors will be orthogonal. Correct? Orthogonal. Eigenvectors will be orthogonal. So these are the properties associated with the matrix. And when you calculate, next step, when you calculate eigenvectors for example lambda minus a, what you are going to get is, we have done na? What you got? 0, -1 and 1. Then for lambda is equal to a, what you will get? 0, 1, 1. You can see that they are orthogonal. And then again lambda is equal to a, what you get? 1, 0, 0. So these are separate questions that can be asked. Eigenvalues is one question, then eigenvector is another question, and let us normalize them also. So this will become 1 by root 2, 1 by root 2, and this will be 1. Correct? These are the eigenvectors. And then I told you to write e to the power a. So how you will write? E to the power minus a, e to the power minus a, and 1 by 2, 0, minus 1, 1, and 0, minus 1, 1, plus e to the power a, 1 by 2, 0, 1, 1, and then 0, 1, 1, plus e to the power a, 1, 0, 0, and 1, 0, 0. So that matrix, can anybody tell me quickly? about that matrix, e to the power a matrix? What is the first row?
e की पावर a 0 0.
No, e to the power a by 2 होगा. This is there or not?
It is there, sir.
e to the power a है only.
By 2
3
is
to power a.
1/2 है कॉमन में.
आपने यहाँ रखा हुआ है. So that will be multiplied to every element, na? Here it will be 0 0. And then 0 e to the power a by 2. Next, minus e to the power minus a plus e to the power a by 2. These elements will be like this. And 0 minus e to the power minus a plus e to the power a by 2 e to the power minus a plus e to the power a by 2. चेक करना जरा, ये सेम आ रहा है?
एक्सक्यूज मी सर. सर जो पहला एलिमेंट है ई रेज टू पावर ए उसके अपोन में 2 नहीं आना चाहिए, क्योंकि जो हम लास्ट वाला देखेंगे ई रेज टू पावर ए थर्ड आइगन वेक्टर से उसमें 1/2 नहीं है,
ये
तो यहाँ
बाकी
पे 2
same
अपॉन
है
2
सर.
नहीं आएगा सर.
क्या थर्ड आइगन वेक्टर देखेंगे तो
जो ई रेज टू पावर ए लिखा है हमने, इसमें जो थर्ड टर्म है हमारे पास, इनकी जब मल्टीप्लाई करेंगे तो इनके साथ 1/2 नहीं आ रहा, लेकिन इन दोनों जो पहली दो टर्म है इनमें 1/2 है सर. तो इसके साथ जो पहला वेक्टर आएगा हमारे पास, पहला एलिमेंट
एक मिनट
मैट्रिक्स का,
रुक जाओ.
उसमें अपॉन 2 नहीं आना चाहिए.
0 0 बाकी दोनों में 0 है ना?
यस सर,
हाँ,
बाकी
ये
दोनों
e
में
to the
0 है
power
सर.
a होगा, e to the power a होगा. करेक्ट. अभी दूसरी तरीके से भी चेक हो जाएगा, डोंट वरी. अब इस मैट्रिक्स का मुझे ट्रेस बताओ. ट्रेस ऑफ e to the power a. Add these terms. Quickly. Add all of them.
2 e to the power a plus e to the power minus a by 2.
2 e to the power a plus
e to the power minus a.
हो गया ना करेक्ट? So that we can see from here na. Minus a are the eigenvalues. So what will be the eigenvalues of e to the power a? E to the power minus a, e to the power a, e to the power a. So please see here. E to the power minus a, e to the power a, e to the power a. So you can see from here that trace should be this. So that is correct.
Yes, sir.
Yes, sir.
यस सर.
So please see this. This is complete cycle starting from here to everything we have wrote eigenvalues. So don't think that in one question so many things will be asked. So these are different questions, different parts of the same problem. Okay. So any one can be asked. For example, only eigenvectors can be asked. Only e to the power a matrix can be asked. Only trace can be asked. Only eigenvalues of e to the power a can be asked. So this was very nice problem and you should do it again. Now, many times like we talk about how to enhance our concept, how to increase the speed, how to increase the understanding. So I will give you one example that suppose this is a question of matrix and you can see that if you do it completely, every concept of matrices is clear from this. You need to know eigenvalues, you need to know eigenvectors, you need to know the Sylvester's theorem, I mean the spectral decomposition. और अगर एक काम और कर लो तो another thing will also be applied. Can I erase this now?
Yes, sir.
अगर आप एक काम और कर लो, because I can write A is equal to P D P inverse. Yes or no?
Yes, sir.
So e to the power A will be equal to P e to the power D P inverse. So this is also a method to calculate. If you can do this, this is the similarity transformation method which I already told you. Then तो अब आप 10 क्वेश्चन करते रहो या एक क्वेश्चन करो और उसमें सब कुछ क्लियर हो जाए. Everything is clear. So this is how you build up the concept. Okay. So now I am taking another problem, and that is a matrix is given capital M is equal to 1 plus iota by under root 2, 1 minus iota by under root 2 and 0. And they have asked what is determinant of exponential m. This is the question. And then options are given. So how to do this? This is a previous year TIFR problem. So you remember what formula I gave you for determinant of e to the power m? So it will become, if you remember, so let me write the solution. Determinant of e to the power m is equal to e to the power trace of m. Correct? This matrix should be m dagger is equal to m. है या नहीं है? So if you take m dagger, what will happen? 1, फिर ये इधर आ जाएगा and iota will be converted to minus iota, तो हो गया. ऐसे इधर हो गया. So m dagger is m. So which matrix is this? Tell me. अभी ये Hermitian है. And so what is trace of m? 1 plus 0, which is 1. And what is determinant of e to the power m? E to the power 1. So that is the answer. Correct? What is the eigenvalues of these matrix? Suppose मैं एक और part में पूछूं, what are the eigenvalues of this m? Can you calculate the eigenvalue? So 1 minus lambda, 1 minus iota by root 2, 1 plus iota by root 2. This determinant value is equal to 0. So what will happen? 1 minus lambda minus, when they will be multiplied, what they will give? Tell me. This into this. Under root 2. Yes. Is equal to 0. So what you will get here? Minus lambda plus lambda square minus under root 2 is equal to 0. जल्दी से बताओ भाई क्या वैल्यू आएगी? लैम्डा स्क्वायर माइनस लैम्डा माइनस अंडर रूट 2 is equal to 0. What values you will get? Minus b plus minus under root b square minus 4ac upon 2a. ये आएगा ना? So what is lambda 1? 1 plus under root 1 plus 4 root 2 by 2. And what is lambda 2? 1 minus under root 1 plus 4 root 2 by 2.
Yes, sir. Under root 2 is 2 हो जाएगा सर ना,
Yes, sir.
denominator sir. Value is lambda square minus
Sir,
lambda.
so it's in the
minus
numerator
1
also 2 will come, so it can.
Here?
सर मल्टीप्लाई जो हो रहा है सर, 1 plus I upon under root 2 और 1 minus I under root 2 सर.
नहीं सर सही है।
सही है सर।
ये नहीं ये सही कह रहे हैं। जब ये मल्टीप्लाई होगा तो यहाँ
सर,
पे
2 हो जाएगा
ये भी
सर।
मल्टीप्लाई होकर 2 हो
2
जाएगा
हो
तो ये 1 आ जाएगा. So this will become 1 actually. Sorry. So this will become क्या आ जाएगा?
Lambda square minus lambda minus 1 equal to 0.
Minus 1 is equal to 0. Okay. And what will be the values of
Yes, sir.
lambda?
minus 2, 3.
2, 3.
2, 3.
Plus 2, 3?
Sir, minus 2, 3.
Or minus 2, 3. So this is minus lambda square we should get, na? Minus lambda square. So minus b plus minus under root b square minus 4ac upon 2a. So it will become 1 plus minus under root 5 upon 2. Okay? So one value
Yes,
will
sir.
be 1 plus under root 5 by 2 and 1 minus under root 5 by 2. So you add them, you will get 1. So that is equal to trace. That is correct. And what will be the determinant value of m? When you multiply, so that will be a square, a plus b, a minus b, a square minus b square by 2. No, when you multiply by 4. So it will be minus 1. Correct? So these are the properties associated with this matrix that I have showed you. एक बार देख लेना सारी चीजें.
सर m into m dagger equal to identity सर है सर.
है ना? वो भी चेक कर लेना. m dagger
हाँ, सर.
into m is equal to identity matrix. And the determinant value is also minus 1. Yes? So those are the properties of what is the property of if it is a complex matrix, na? It was a complex matrix.
Yes, sir.
So u dagger u is equal to identity matrix. Correct? So if you apply u inverse on both sides, so you will get u dagger is equal to u inverse. So this is properties of, you can check this also. अगर आपको inverse निकालना हो तो it will be just equal to u dagger. Okay? So these are the properties of, and its determinant value will be always either 1 or minus 1. The determinant values will be either 1 or minus 1. So these
Sir, सर जो अभी हमने प्रॉब्लम सॉल्व की है उसमें तो m डैगर m के इक्वल है, तो वो ये वाली ये सेकंड कंडीशन कैसे फॉलो करेगा जो हमने u डैगर u इज इक्वल टू आइडेंटिटी से निकाली है?
m dagger m किसके इक्वल?
अभी उन्होंने बोला आइडेंटिटी आएगा,
नहीं आ रहा है सर.
m dagger
आइडेंटिटी नहीं आ रहा सर इसमें.
m dagger m I आ रहा है?
नो सर इसमें नहीं आ रहा.
नो सर.
कोई बात नहीं, मैंने इसीलिए अलग से U लिख दिया है। अगर ये है तो ये सब प्रॉपर्टीज फॉलो होंगी, ये नोट कर लो अलग से। दिस इज फॉर यूनिटरी मैट्रिक्स। And one more important thing for unitary matrix, I told you that its eigenvalues will lie on the unit circle. So any modulus of eigenvalues will always give 1. Correct? इसके eigenvalues हमेशा किस पे लाई करते हैं? यूनिट सर्कल पे। तो उसकी मॉडुलस वैल्यू हमेशा 1 होगी। ओके, सो अनदर क्वेश्चन आई एम टेकिंग। देयर इज अ मैट्रिक्स गिवन A is equal to 100 root 2 minus x 0 x 0 x and 0 minus x and 100 root 2. This is the matrix, and it is also given that x is a positive number, and it is also given that it has two equal eigenvalues. Two equal eigenvalues. Okay, two equal eigenvalues, and we have to just find the values of x. This is the question. So the solution is like this. So this is also a TIFR question. This gives lot of insight actually. जब ऐसे क्वेश्चन आप करते हो तो you get confident about doing so many other questions, and just properties will be used, nothing else. So please see the solution. So this is a 3 cross 3 matrix, correct? Yes, it is a 3 cross 3 matrix. So 3 eigenvalues will be there.
Yes, sir.
So if 3 eigenvalues will be there, so that means lambda 1, and lambda 2 should be the eigenvalues. Do you agree with this?
Yes, sir.
Yes.
Why lambda 1, lambda 1? Because it is given in the question that two eigenvalues are equal, correct? So now I have used what was given in the question, and one thing more is given, that x is positive, that also we will use somewhere. Okay, so now the first thing is that a minus lambda I is equal to 0 for eigenvalues. So what will be this will be, if I write a minus lambda I is equal to 0, so it will become minus lambda, and minus lambda. Okay, correct? So it will become 100 under root 2 minus lambda into multiplication of this will become minus lambda 100 root 2 and plus x square. This will be the first one, and the second one will be minus x.
So
And
there is a plus lambda square also, na? Lambda square. Plus lambda square also in the second term.
oh sorry, this na, I missed this because of this is minus lambda, so it will become minus lambda into 100 root 2 plus lambda square and then plus x square, like this. Is it okay?
Yes, sir.
And what about here? Minus x into minus x 100 root 2 minus lambda and minus 0. This is equal to 0. Is that okay? So I can take 100 under root 2 minus lambda and all other thing is equal to 0. So one root came out to be lambda is equal to 100 under root 2. One eigenvalue. Yes or no?
सर
Hmm?
एक्स लेमडा से भी तो मल्टीप्लाई होगा ना, माइनस एक्स 100√2 लिखा ना सर आपने। अच्छा अच्छा सर ठीक।
So this will again come common, na? This thing. You can take this as a common. Because this is here also and here also, na? So you can take this outside or not. Whatever is there, right here. And
Yes, sir.
so this is the first eigenvalue. 100 for this matrix A. Now we have two other eigenvalues that we need to calculate, and let us take them as lambda 1 and lambda 2. Suppose this is lambda 2, and then we have two different eigenvalues that we need to calculate. Okay. Now the first property that I am going to apply is, so we need other equations also. So let me write my original matrix capital A, and let me just write this, the original matrix capital A. So what is the trace of the matrix A? Trace is 2 lambda 1 plus lambda 2 is equal to 200√2. Yes or no? The trace of the matrix. And also the determinant of the matrix is lambda 1 into lambda 1 into lambda 2 is equal to. Calculate the determinant of this quickly. The determinant value. Check this. This is the determinant, which is the product of eigenvalues.
Yes, sir.
Yes, sir.
Everybody knows now how to calculate determinant. So we have 2 lambda 1 plus 100√2. So I can write here 2 lambda 1 plus 100√2 is equal to 200√2. So from here I can write 2 lambda 1 is equal to what? 100√2. So what is lambda 1? It is 50√2. Check this. And using this I can write 50√2 into 50√2 into 100√2 is equal to 200√2 x square. So it will be this and 2 and then 2 get cancelled. So 2500 is equal to x square. So x is equal to 50. This is the way I have done. If you have any other way, you in maths you are always free to do that.
So here we considered lambda 2 to be 100√2. But what if we consider lambda 1 to be 100√2? Like,
Because you know, I am not sure that this value will come twice. So
yes,
I have taken the other value which is not the same. I have taken that. अगर वो सेम आना हुआ तो फिर से आ जाएगा. ओके वो तो बहुत पर्टिकुलर बात हो गई कि वही वाली वैल्यू सेम हो. सो दैट्स व्हाई आई हैव नॉट taken that. 25,
Yes,
100,
sir.
it is okay, na? So this is okay? Question is okay?
हेलो सर
Hmm?
तो इससे पहले क्वेश्चन करा था आपने अभी एम डेगर इनटू एम इक्वल टू आइडेंटिटी आ रहा सर
Hmm.
सर वो सही है क्वेश्चन
अब कोई बात नहीं, आप चेक कर लेना, क्योंकि उसमें वो यूज नहीं हो रहा है, मैं तो जस्ट ऐसे ही अलग से बता रहा था, तो वो करके देख लेना. If that is the case, then it is a unitary matrix. Okay? Because sometimes they directly ask that whether the given matrix is unitary matrix or not. So you have to check U dagger U should be equal to identity matrix. तो ये हमेशा याद रखना कि the property that I applied for spectral decomposition only works for Hermitian matrix or symmetric matrix. For no other matrix that will work. Okay. So there is another question, and that will also give you a lot of insight, that they have given that U is unitary matrix. U is unitary matrix, and a unitary matrix U is expanded in terms of Hermitian matrix H, and H is a Hermitian matrix. Hermitian matrix, and they have given that U is equal to e to the power I iota pi h by 2, iota pi h by 2. This is also given, and h is given half 0 under root 3 by 2 0 root 3 by 2 0 1 0 minus half. Let me check it again. Half 0 root 3 by 2 0 1 0 root 3 by 2 0 and minus half. This is the, so the question is, what is the value of U? So how you will go? How you will go about this? So basically you have H given and you need to calculate U. That is the question. कैसे करेंगे भाई? And this is given that H is Hermitian matrix. So you can follow two different ways, and this time let me follow the other way. Quickly I will write everything. Suppose I want to do it, I will write it like this. U, first of all, H is equal to P D P inverse. Yes, बोलो भाई. And e to the power I pi h by 2 will be equal to P e to the power I pi d by 2 P inverse. You agree or not? So this time I am using similarity transformation. Similarity transformation. This is again a question. So this time I am using similarity transformation. So how, what are the steps? क्या बताया था मैंने? कोई बता सकता है जल्दी से? Can you tell?
Sir, eigenvalue,
Eigenvalues, very good. So eigenvalues. So let me give you that. आप बाद में निकाल भी लेना. It is 1 1 minus 1. 1 1 and minus 1. Degenerate eigenvalues 1 1 and minus 1. And let me give you the eigenvectors also. 0 1 0. Note down this also and ये आप कर लेना दोबारा. √3 0 1. √3 0 and 1 and √3 by 2 0 and half. So these are normalized eigenvectors. These are, please write, these are normalized eigenvectors. No, just wait. ये दोनों same ही है. After normalization it is this. 1 and 1 के corresponding आ गया. And for -1 the vector is, ये भी note कर लो, ये भी calculate कर लेना. For -1 it is -half 0 √3 by 2. Please check quickly they are orthogonal or not. x1, x2 and x3. Please check they are orthogonal or not. For example, this 0 0 0. Perfect. 0 0 0. Okay. And this, इसको ध्यान से, -√3 by 4. This has got problem. No, it is normalized. मतलब before it will be orthonormal जरूरी नहीं है वो, orthogonal होना चाहिए. तो इससे पहले वाले स्टेप में वो orthogonal है. Okay. बाद में normalize कर दिया गया है. If you want to write that also, √3 0 1. It was √3 0 and 1, and then it was normalized. It was normalized to this. So it is orthogonal. Orthogonal. It may or may not be orthonormal. That is another thing. But it is orthogonal. So now you have P matrix. So let me write now how you will write the value of H now in terms of this similarity transformation. So you will write H is equal to PD P inverse. So the value of H will be equal to, so you will write a matrix which is made up of 0 1 0 0 1 0 and √3 by 2 0 half and -1 by 2 0 √3 by 2. This is P matrix, and then you want to write H, and then you will write a D, and you will write its inverse here, inverse of P. So it will become 0 1 0 and √3 by 2 0 half and -half 0 √3 by 2. Okay, so now whatever will go here, so it will become e to the power I pi h by 2. So this will remain same, and here it will become e to the power, so e to the power I pi d by 2, and here it will remain same. and then you have to multiply all these three matrices, and what you are going to get is, just note down here, what you are going to get is finally a matrix which is I by 2, 0, root 3 I by 2, 0 I 0, and root 3 I by 2, 0 minus I by 2, minus I by 2. So this much you have to do. So this will be finally your U. So sometimes what will happen, that they have given that calculate the value of U. Please remember this and note this as a important point. They will ask what is U and the method is lengthy, you can see. But what will happen, out of 4 options only one matrix will be unitary matrix. So you can quickly just guess out of the options that this is the unitary matrix, so this can be only the possible answer. Write this as a note.
Yes,
Yes, sir.
इसको as a note लिखना जरा, that out of 4 options sometimes only one option is unitary, and which is the obvious solution of this question. Which is the obvious solution of this question?